Hello everyone, my name is Ori. I and Dekel and Shlomo wants to present our presentation about fuel and problems that connected to fuel supply in space. This is the main map. The main map helps us to organize information and to divide in two branches. The main map split to 5 branches: evaluation, prediction, equipment, safety, and method. We will expand about every branch in the presentation.
Hello, my name is Shlomo, and I would like to talk about the problems. Well, the main problem is that spacecraft cannot carry large capacity of fuel, and because of that they cannot reach long distance. And we think that long distance missions are necessary for human research, so we've come up with our solution. Basically, the solution is to create a supply system of fuel, and we've divided it into 4 steps. Step 1: add a fuel storage unit to the International Space Station. We believe that this is better to use an existing station instead of building new one for this purpose. I have to say the storage unit will be empty at the beginning, and this leads me to the step 2. Send a small amount of fuel on every shuttle voyage. Already today NASA sends from the Earth to ISS shuttled with food and oxygen, and we want that those shuttles will fill up little by little our storage. And step 3 and 4 are the heart of our solution. The moon station is basically an station that will orbit the moon, and we talk about this more later. Step 1. Today ISS is used for researchers. They check the reaction of the human body in a non-gravity condition. ISS will finish their job in 2020, and we want to convert it to an operation station. As I said before, assembly fuel unit for storage, and this unit will be empty, and prepare staff of space builders. The idea is to prepare those people, those astronauts, to build up to convert the ISS from researcher station to operation station. And step 2. Today ISS has a regular supply of necessary things, as I said before, food and oxygen, and we want to use this regular supply to fill up the main storage in ISS little by little. We can use the existing autonomous spacecraft and also the manned spacecraft in order to reach our goal. And now Dekel will talk about the unmanned spacecraft.
Hello everyone, I'm Dekel and I'm gonna to speak with you today and introduce from you the vehicles, or actually the spacecraft, that will serve our program of system of fuel supply in the outer space. This branch is divided to 2 topics. The first one is the already exist spacecraft that serve today the ISS, International Space Station, for resupply and other things. And the second one is the spacecraft of the future that will serve also the Moon orbiting station, and generally will can to reach to greater distance places, and also to stay more time in the space. So we discussed today about few things: technical details, the way they are launching and docking. We also watch a video about it, and we will talk a little about the origin of those spacecraft. The first one and the most used spacecraft is the Progress. The Progress is an unmanned cargo spacecraft that made by Russian, and in the past this is used for the space station of the Russia that today not exist anymore. Therefore, this is used today for the ISS, for resupply and other things. The Progress is very similar to the Soyuz. The Soyuz, for who not know, this is the spacecraft that carry on the people, the astronaut and the cosmonaut to the space station. Actually, the Progress is a version of the Soyuz for cargo and not people. It's also launch for the launcher of the Soyuz. In the space, the Progress is navigation automatically and also docking automatically in the space station. There is control panel on the Earth that's supervising about the operation of the spacecraft and get involved just in case that something goes wrong. Here is a little video about how the Progress is launched. So here you can see the launching of the Progress. This is in standing by status now, and the engine is start now getting a turbo speed. Now it's already on flight speed and ready to lift on, and in a moment it is lift on right now and start it journey to the ISS. For the launching, the Progress need a great amount of energy to pass the atmosphere and accumulate an altitude that is enough to orbiting the Earth. After it is past the atmosphere, the unnecessary part is separate from the spacecraft, as you can see here. This is the button agents for the launching. It is separate now, and just the main parts is remaining, as you can see right here. Okay, and this button part is already separate. In just a moment, in here you can see it fell down, and this is the last part that stay and reach to the ISS. Actually, that's just this little one. So now I can show you how the Progress is docking and how it is simple and easy. Okay, so this is video from the recent time, as you can see, and here you can see the outside black and white camera of the Progress is approaching to the ISS. Here in the screen you can see all the parameters of the Progress. This is the distance remaining from the destination, the International Space Station, and in a few moments you can see also the ISS capturing a picture in a video, the Progress above the Earth. Very amazing picture. So here is approaching, and you can see how it's connecting, how it's docking. This is other Progress. This already connect to the ISS, and here is our new Progress arriving and docking. Here is happening. This is from the camera outside the Progress. This is Apple now, the docking. Accurate, easy and automatically operated. A few more details about the Progress. Here you can see the launch mass, and the mass of the cargo is remaining After separate the unnecessary part on the space, the part is actually responsible for the launching and the past the atmosphere. The big engine you can saw on the video are separate from the progress after they pass the atmosphere and connecting to the orbit. So here you can see the liquid cargo mass is a little more off from the total cargo mass. The liquid is what important for us. We want, after all, to transfer fuel for the International Space Station. Here you can see a simple structure of the progress. Here is the solar panel that is responsible for create energy for the vehicle. Here is the antenna that is responsible to the connection to the Earth, to the panel control, supervising on the spacecraft. And this is the part that connects to the station. Here you can see the ball tanks. It is the tanks for storage liquid cargo, also fuel, of course. That's what we want, to transfer fuel. As I said before, the most used spacecraft for resupply and transfer fuel to the ISS is the Progress. But except of this, there are two more vehicle spacecraft that do this. The first one is the Unmanned Spacecraft ATV, Automated Transfer Vehicle. This is developed by the European Space Agency for providing resupply to ISS. This is supply all the stuff the station needs: fuel, water, oxygen, food, and scientific research equipment. This is routinely launched every 17 months. Important to say, this is less from the Progress. This is launched from France Space Center by launcher Ariane 5, as it can be used also in a version of a manned spacecraft for 4 or 5 crew members. This is launch and docking very similar way to the Progress. Here you can see the structure of the spacecraft, the solar panel, the tank of the liquid and gas. We can transfer it, fuel of course, and this is the part that connects to the station in the space. Very simple docking. The third and the last is the Dragon, also unmanned spacecraft. It is developed by a private American company called Spacecraft, and in origin this is developed and designed for human travel, but actually is used today for the resupply and deliver cargo to the ISS. This is launched by the launcher Falcon 9V 1.0 that located in California. Here you can see a demonstration of the launch vehicle of the Dragon and the Dragon itself, and this is compression between the Dragon for cargo and the Dragon for crew. This is all what you need to know about nowadays spacecraft. Thanks for listening.
Thank you, Dekel. Now I'm going to talk about the third step, the heart of our solution, Moon Orbiting Station, or in short, MOSS. We call it MOSS because it sounds like a moss. Well, at first we need to transfer the storage unit from ISS, which we filled up, as I said previously, and assemble it to the MOSS. Basically, the MOSS is, as it sounds, orbiting station. It will orbit the moon and won't land on the moon at all. The main idea is that every spacecraft which launch from the Earth won't land on the moon and just dock to the Moss. This is very good advancement because we need a lot of energy to retake off and relaunch from the moon, from a planet. And here we don't spend this energy. We dock to the Moss, and after we dock on the Moss, we refuel our spacecraft, and after it we disconnect from the Moss and move on to the other planet maybe, and we will achieve our goal to go long distance. Well, basically the Moss is used for indeterminate stops to those spacecraft. And now Ori will talk about the pros and cons.
Pros and cons. We will talk about them, and we will start with the pros. So, the first one is longer flight paths. If we can supply more fuel, and to be assisted by ISS and Moss, we can fly to long distance and explore new places. The second one is backup to shuttles that are located near the Moss or ISS. If any shuttle need help, need fuel supply, Moss and ISS will supply fuel or safe place for the astronauts. Long stay near the moon and study of it. Most close to the moon, and she is manned. The long stay near the moon can help us to study about him and send to their astronauts in high frequency. There is no need to land on moon. The process of landing is expensive. It is dangerous for the staff or to the shuttle. Most ISS can connect easily to any shuttle. The cons. Expensive building the new space station. Build Moss will be expensive project, but is necessary. Expensive converting the old space station into a gas station. The first phase before building Moss is to convert ISS to gas station. Risk lives of more astronauts than manning the new space station. Most will be manned, and we know that to send people to outer space is dangerous mission. More garbage in the space. If we open new station and we have to convert the old one to gas station, a lot of garbage will be sent in space, like working tools, nails, and food. In addition, add more stuff, increase the chance to dirty the other space. Building forecast 2030. It will be take 1 decade and maybe more, and that very long time for build a space station. We will finish. Thank you for listening to us.